So, I'm going to talk about automated testing and how we do automated testing at Opera. First of all, a little bit about myself. I'm the co-author of Operwatir, which I presented on the Water Day. And I'm also committed to Opera Driver, which is pretty new. It was released now in December. I'm also an Opera lover, so I have chosen the right place to work. And I'm a QA engineer at Opera, at that big A. Now you see, I couldn't fit it on one slide, so I had to use two because it's so big. Now, writing a web browser is a tough job. But unlike other dangerous things you might end up doing, we do in fact explicitly encourage you to do so. I would perhaps like to make the argument that writing a web browser, I'd like to make the argument that the web browser is probably one of the most complex pieces of software that you can probably write on the computer, perhaps after the operating system itself. When I started working with Opera, I used to do normal QA duties with a docs module, which is basically an HTML parsing module. And I must tell you, I get surprised every time I open a web browser and I see that it actually works. Because I think when you've been inside of QA for a couple of years, you sort of expect things to go wrong. And to be honest, with all the strange things that's going on when you look at the protocols and the standards on the web, I'm really surprised that the web actually works. To share one example, you may have heard about this thing called HTML5. Well, it doesn't really matter whether you heard about HTML5 because the version numbering is gone, so you just have to know about the HTML. But basically, to make a long story short, the web browser vendors have been starting to trying to play catch up with the web developers for the past 20 years. The HTML5 specification needs to answer two questions. First, as an author, how should I write an HTML document? HTML5 is stricter in this regard than any previous HTML5 specification. Second, as a web browser, how should I parse and interpret this unholy mess you all incompetent authors have conjured up over the past 20 years? Yes. Can we find a way to parse both the 1% of valid documents and the remaining 99% of the invalid documents using the same parser? And that poses an interesting problem. Most of you already know this, but seeing as all the previous specs for the web had sucked, the HTML5 spec essentially specifies all the broken behavior, or should I say, how to make the web work with backwards compliant support for old browsers. It turns out, yes, we actually can. For the first time in history, both your beautiful, well-formed website and your front page generated abomination will be parsed as in a predictable manner, the same way in every browser. A number of people question why we bother parsing content that is simply broken. Wouldn't it be better if everyone just did the right thing? Oh, certainly. Nothing would be better. But if Facebook, which by the way has 65 validation errors, or the New York Times, which by the way has 274 validation errors, stop working in Opera, you stop using the browser and you start using something else. Now, every time we fix a bug in Opera, there's about a 30% chance of us introducing a new bug in the process. This is a high number. If you're into software development, you know that 30% regression rate for a bug fix is a high number. Now, I know that in certain parts of Opera, like we have a team called the Site Compat team, which basically comes up with live patches for things like Google, because Google breaks all the time. We often have a regression rate of up to 50%. This means that we have to test our browsers properly. Now, one way of reducing regressions is to do regression testing. We do regression testing against test cases for fixed or reported bugs, as well as against specification test suites. We use regression reports not only to validate the correctness in the browser, but also for tracking the quality of the browser itself. We do everything from unit testing to functional testing to high-level interaction testing. But I'll get back to that in a moment. Other types of testing might include stability testing. Stability is a huge issue for web browsers, but it's often very hard to track down where crashes occur. Often a huge list of requirements must be filled for a crash to occur. You might have to, say, visit 1,000 pages in a set order for a crash to be reproducible. Or even in some cases, tens of thousands of pages. When the browser crashes, many people report their crashes back to the browser vendor. And this gets stored in a big database alongside a randomly generated list of URLs, which we use for, which we simply load into the browser in using an automated tool and basically check if the browser crashes. So this is kind of completely random testing, but in fact, we do catch quite a lot of bugs just doing this. This tool that we use for just going through the different URLs, we often run on people's own workstations. So say when you go home from work, people are encouraged to just run this tool to utilize machine power better. Another way to detect crashes is to generate junk, literally. So we write fuzzers that exploit certain known areas and unknown areas in the browser that we know are vulnerable. When it finds the crash is recorded, and a QA typically makes a crash test case for which it can be used for later regression tests, which we can use in regression testing. We also do performance testing. I'm going to show you a brief, this is an example of a performance report. So we see that the certain test cases here are way over what they should be. Our performance testing is still pretty basic, but we're already catching bugs with it. And we're also having automated regression testing, and the regression reports also look kind of similar. So you have a list where you compare one build that you know that you want to compare against, and a build that you want to test. And then we have different statuses for this list. Now, I'd like to tell you a success story of automated testing. A couple of years ago, tests for Opera were mainly run manually. As with any software company, we also have a shortage of testers. The ratio of developer per tester at Opera is about 2 to 1. A couple of years ago, we started focusing on automated regression testing. Now we run almost all our tests automated. This means that we can tighten the quality control of new builds. When a new build is in integration phase, we require it to have no regressions. So we created a tool called Spartan, which is an automated regression testing tool. But the testing tool, or the regression tool that we run every new integration build through, is also actually useful for individual developers. I think sort of we're coming to a point where the usefulness of letting individual developers and testers request automated testing on a build they compile themselves, or a subset of tests that they want to retest, is going to be quite useful. So we're sort of developing our regression testing tools from just being a tool where we just filter every new build through to a place where you can go and request a new testing of a build. This means that you also have, of course, have access to the test machines that we use for regression testing. Now we have about 160 Linux machines and about 20 Windows machines. We're adding a bunch of new Windows machines, but basically maintaining Windows machine is a hassle. Unfortunately, so I'm going to show you some numbers. We have about 100 developers and testers in core. That's the group of people that makes the actual browser inside without all the GUI and the user interface. We have about 180 testing slaves, and we in total have about 200,000 tests. Now, each single day, Opera is compiled in such a way that we have different profiles for Opera. So we have one profile for desktop. We have one profile for like desktop that you run on your own computer. We have one profile for phones. We have one profile for smartphones, one for TV, and so forth. So these have slightly different capabilities. So each day we run about 50 to 30 profiles, or testing on 5 to 30 profiles each day. And in general, this generates about between 1 million and 6 million results each day. So doing this, going through all these reports manually isn't an option. We need a system for analyzing all these reports and telling us the useful things so that the humans can spend more time on the things that humans are good at. But by far the biggest issue we have in our testing is stability. Because we're not just doing JUnit testing with Selenium, or we're not just doing water testing with RSpec. For our regression reports to be useful for humans, they need to be clinically sterile of false positives and other bad outcomes caused by external factors. These factors may include, but are not limited to, problems with the tests themselves, bugs in the testing software, parsing bugs in Spartan, the testing tool, network outage, well, basically the machines are down, sysadmins tripping in cables, or the wrong moon phase, and so forth. To illustrate this, we used to have a bug related to dates in Opera's cookies implementation. The test for this, for our cookies implementation, ran fine most of the time. But then they suddenly started failing at seemingly random times. We reviewed all the test cases and couldn't find any issues. So we began looking for what might be causing the randomness in our testing tools. Naturally. It turned out, however, that this was a sort of moon phase type bug, where the bug in the dates in the cookies only occurred on the 31st of each month. So this is the sort of issue that we run into often, where we have seemingly random results in our testing or regression reports, but which are not random. And this is hard to test. So every time you add a new test to the system, there is a risk for introducing more randomness. There may be factors you haven't taken into consideration. For instance, that a test may behave differently on a slave machine and on your local machine. Or that the build we're testing against might be using a different configuration, and so forth. Because sometimes you might be running Opera in full screen, or sometimes you might be running in presentation mode like I am now. So, and this impacts the quality of the test also. Now, we've started employing a system we call quarantine quite recently. And basically, every new test that is submitted to the system goes through a quarantine phase, which means that new tests won't show up in the regression reports. You can choose to show them if you want, because they're tested equally alongside all the stable tests. But in the fear of adding randomness or bad results to the testing system, we're sort of keeping them in quarantine until we can verify that they're good. And this is we find that this is a good approach if you're having a lot of bad behavior of tests. So basically, once in a while, we go through the quarantine list, see which tests are behaving badly, analyze them, and we have an automated tool for this, and then we can just push a button, and all the unstable tests are moved into the unstable branch. And unstable tests are also run regularly, but not as often as stable tests. This is a list of the different tests that we have in our system. We have visual tests, which are basically screenshots. So we take a web page and take a screenshot of it and compare it with an old screenshot that we've stored from before. We have reference tests, which is the new kind of visual test, where you basically take a screenshot of one page, then go to another page, which renders the reference of that page, and compare them. So if they're different, then it's a fail. We have JavaScript tests, a lot of JavaScript tests. These are very cheap to run. We have crashing tests, which have been filed from the system that I told you about earlier. And we have performance tests, also self-tests, memory tests, and water tests. Now, implicitly, water test also means that you're using Selenium, and I'm coming back to why. Self-tests are written in C++, and they are basically calling native C++ code inside of Opera. I'm going to go quickly through this. We have also do memory testing on basically everything from JS to DOM and images to systematic auto memory issues. And the way we do that is by enabling full memory logging inside of builds. Now to the exciting part of my presentation, I find. Traditionally, Selenium has been used for web application testing. At Opera, we've started using Selenium for testing the actual browser itself. This means that we're turning the situation upside down, like this. Opera Driver and Water was released in December 2010. Water is still a separate project, but it's bound to be merged into Water WebDriver. Opera Driver is also soon going to come into Selenium, so that you'll have access to Opera Driver along all the other devices from Selenium. I also did a talk on Operwatir on the Water Day, and my presentation slides are also out for that if you're more interested. The thing that differs Opera from other Selenium implementations is that we use something in the backend called the scope protocol. This enables us to connect to devices directly. So we can do testing on cell phones. So this is the scope protocol is native inside of Opera, so we can run the device on. You don't have to be running Selenium on the same computer. I have a small demo because I forgot to bring along a cell phone from the office. And here you actually see Selenium running on a cell phone. And we're actually in the process of setting up this in our testing lab, so that along all these testing slaves, we'll also be using, we'll have sysadmin set up small phones next to all the big slaves and all the big testing boxes. Operwatir running RSpec. This is the way that we typically write our tests, because we decided that we wanted testers to make it easy to add new tests, and it's a bit tougher to learn Java in our opinion. So that's the reason why we added RSpec and Water. But it's still possible to write JUnit test and Selenium test for the developers who prefer Java. And here's Opera Driver running JUnit. I was going to talk about examples of bad tests. I see that I have little time left, but I'm going to go quickly through it. This is an example of a typically bad visual test, which I told you about earlier. So this test, if we store a screenshot of this test, it might look different on different machines because the font might be different on different architectures and different web browsers or different iterations of Opera. So a better approach would be to add a reference. And we've actually added capability inside of Opera driver to take a screenshot of an element on a page. So you can actually say div test and take a screenshot of that, do a hash comparison to the reference. So you can actually save about 50% of the time taking to run a reference test just by having the test and the reference on the same page. Now, I'm going to talk briefly about standardization because I know that this has come up recently. I think that we have been talking recently about doing automation APIs. What if we could make Selenium sort of a standardized automation API native to the browser? This offers very interesting thoughts, especially if we can get vendors to actually provide the implementations of Selenium or the method for communicating with Selenium themselves. And this is exactly what we're doing at Opera. So at Opera, we have developed Opera driver internally. So we also have access to all the internals in Opera. So you can say like get preference or iterate through all the preferences, set a preference, reload Opera, start a new test, open a dialog, go into a dialog, enter some text into the preference dialog, and so forth. So we're basically employing Selenium as a tool for testing the entire browser. And of course, all of this will be available for outside of Opera as well. So it has a clear benefit, not only for browser testing, which we are interested in, but also for web application automation. And we see this as a sort of a two-sided thing, because if we can make people use Opera driver for their web application testing, that is also going to benefit us. So that's what I had. Thank you.